All right, we're going to start off here with some review. So we'll evaluate some logs here. And so we're just going to let this first one equal x. And then we'll do our exponential switch. So we're going to say 7 to the power of x equals 1 over 49. And then, let's see. First of all, since I see it's in the denominator, I know we're talking about a negative exponent here. And so I'm going to say x equals -2 because the negative is going to drop it down to the bottom. And then the squared is going to turn it into 49. All right, so that's it. Next up, number 3. So once again, let this equal x, and then we'll switch it to exponential form. So the base is 2 to the power of x equals 8. And then, so I know that this is not 4 because it's an exponent here, so it's x to the third power would give you 8. All right, next up we're going to expand each logarithm. And so for these ones, remember that everything that from the numerator ends up in a positive exponent, and everything from the denominator ends up, or not an exponent, a log. Everything from the denominator ends up in a negative log. So we're going to call this log base 5 of u to the fourth minus log base 5 of w minus log base 5 of v squared. However, I need to now move those exponents out to the front. And so I'll do that up here. So our final answer will be 4 times log base 5 of u minus log base 5 of w minus 2 times log base 5 of v. So that'll be my final answer there. So you can see, like I said, everything from the numerator gets its own positive log. Everything from the denominator gets its own negative log. Next up, these ones, we're going to first move we are going to condense all these to a single logarithm, but first I'm going to move up the exponents. And so that's that. And so I'm actually going to cross that off and just put a fourth power. We'll cross that off and put a fourth power. And then we'll cross that off and put an eighth power there. So we don't have to write it all over again. Okay, so now we're going to condense it all into a single logarithm. So we're going to go log base 2, since all of these are base 2. I'm going to build a fraction in there. Everything from the numerator is going to go in positive. Everything from the denominator is going to be from the negative logs. So x to the fourth was in a positive log, so that's up top. Z to the fourth was from a negative log, so that's going on bottom. And then y to the eighth is also going on bottom. All right, next up we got our first new thing today called change of base formula. So change of base formula allows you to use a calculator on these ones right here. So if you kind of think about like number 9, for example, so I'll skip ahead here. If we tried our kind of old method here of saying 3 to the power of x equals 40, we're not going to be able to figure that out. There's no power that turns 3 into 40, so this actually is not going to work. So there's another way that you can do this, and that's called the change of base formula. So the change of the base formula says that log base b of, let's call it a, equals log a over log b. And so you can see that we're putting both of these in base 10. Technically, you could use whatever base you want, but calculators by default always use base 10 because they just have kind of the log button there. And I kind of always remember the order here because the A is kind of above the B here. And you can see the A is still above the B here, but it's kind of, they're in their own logs now. But we've changed the base now from a base B, whatever it was, into a base 10. Because, like I said, the calculator has a base 10. So for number 9 here, instead of doing what we were trying to do there, we were just going to do log 40 divided by log 3. So now we're going to use a calculator for this. Now, I actually don't like the way that the iPhone calculator does this, so I'd actually recommend that you go on Desmos.com or some other graphing calculator. If you just Google, or sorry, not graphing, if you just Google scientific calculator, then you're going to find a good one for this. Desmos is a great one, so you can, on Desmos, you can literally just type it in like this, log 40 divided by log 3, and so I'm going to type that into decimals. So log 40 divided by log 3. And just make sure it looks exactly like this. And so if you do that for this one, you should get that this comes out to 3.358. I'm going to round that up. It says the nearest thousandth, so that's supposed to be 3 digits. Remember, tenths is 1 digit, hundredths is 2 digits, and thousandths is 3 digits. Okay, so that's that. It should be really quick, really easy. So number 11, I'm just going to type in log 51 divided by log 5. And so for that, we get 2.443. All right, we're actually going to do a little more review here, and then we're going to get into some new stuff. So on these ones right here, we used to do these before where you can turn this one into 7 squared. And then once you have them to be the same base, then you can set the exponents equal to each other. And this was last unit, and so we get 2n equals 3. And so n equals 3 over 2. But you can see that when we get down here, that on number 15, for example, and the first step we're going to do on number 15 is we're going to add this 4 over. And we get 3 to the x equals 41. And I can't do that trick here. I can't turn 41 into some base of 3. So that brings us to our new thing here, which is solving exponential equations not in the same base family. The key here is, well, first of all, actually I should have said 2 steps. First step, isolate the base. And so that's kind of what I did there with the adding the 4 over. This will be step 1. And then step 2 is going to be use a log. So I'm going to switch this into log form. And so we're going to call this now log with a base 3. And then the new partner is going to be 41, and that's going to equal x. And so now that I know my new trick for change of base formula, I'm going to go to the calculator, and I'm going to say log 41 over log 3 equals x. Let's type that in. And so that would mean that x on this one equals 3.380. If you took it out to 3 decimal spots. So it's kind of applying the new thing we learned right there. Okay, so then next up, number 17. Now I do need to do step 1 first, which is isolate the base. The base here is 18. I need to divide this 2 over. I'm not allowed to multiply 2 and 18 together because of the exponent. So I'm going to say 18 to the power of m equals 3. Obviously, I can't turn 18 into 3 using exponents. And so I'm going to switch it to log form. And so log form, my step 2 will be log base 18 of 3 equals m. But to type that in the calculator, I'm going to do log 3 divided by log 18. And so when I do that, I get 0.3801 if I round it up. All right, so that's that. So you guys try the even ones. Bye.